In this video, we're going to solve another practice question on location optimization. Question number 12 from chapter 12. So I have the question here. This question is in continuation of problem 10. We're working with the same data, with the same metrics, adjacency metrics from question number 10, except that in this question, we have the population of each county, and the formulation is going to be slightly different from problem 10 because now we're looking at a different objective function. So now in part A, assume that only a fixed number of PPBs denoted K can be established. So the number of PPBs before in problem 10 was our objective function. We wanted to minimize that. But now we are going to define it as a constraint. So we're going to make sure that this is defined as a constraint. However, our objective function is going to be to maximize the population reached, the population of locations where you can cover the counties that you can actually have a branch there, you can operate there, right? So we want to know how to locate the facilities, how to locate our PPBs, how to locate the fixed number of PPBs in order to maximize the population reached. All right, and then so this will give us a hint here. Review the Ohio Trust formulation in section 12.4. Introduce variable y I equal to 1 if it's possible to establish a branch in county I. So this is different with xi that we defined in question 10. For xi, the decision was whether or not to establish a PPB. Now, yi tells us whether you can operate in county I, whether you can establish a branch in a county. All right, and 0 otherwise. That's if county I is covered by a PPB. So when yi is 1, it means that there is an eligible PPB nearby, either at the same county or at an adjacent county. All right. The population can be counted as the reached population or as covered population. And then in part B, it gives us a value for K, let's say 2 PPB. So K equal to 2 is, you basically put K equal to 2 and solve the problem. And we have the data in the next sheet here. All right, where should they be located to maximize the population served? And then in part C, it asks to solve it for different values of K equal to 1 to 10, all the way to 10. So you increase K 1 by 1 and record the population, the objective function, the population reached, all right? And then you draw a graph. You can draw a line chart or a column chart. And then you see where you should stop building new PPBs, all right? So it says adding an additional PPB will make sense only if the increased population reached is at least 500,000. Otherwise, you should not add the new PPB. So you're gonna do this part C by yourself. But I believe once you see the formulation, once you see how to solve it for a K equal to 2, you should be able to do it easily for the part C. You just need to plug different numbers into the constraint. Instead of K2, you can put 1 all the way to 10. And each time just record the population, draw the graph, draw the line chart or bar or column chart, and then just check the additional population reached after you add K. And as soon as the increase in population reached is less than 500, 1,000 people, you will stop adding new PPBs. All right, so we're gonna solve only part A and B in this part. So for part A, the formulation, we had xi's, decision variables. We had xi's, and we have two sets of decision variables. We had xi's, whether or not to build a PPB at location or at county I. Yi, whether or not county I is covered, meaning that there is at least one PPB nearby. And by nearby, I mean it should be PPB, should be either at location I or at one of its neighbors. So that's when you can say location I or county I is covered. All right, and then both xi's and yi's, which we have 88 of each, they are binary variables. So 0 or 1. Same thing for the other one. 0 or 1. All right. So that's the decision variables. Objective function. Objective function in this question is the population. You want to maximize population reached, which is equal to, so we want to maximize the population that we reach by building these PPBs. So for this one, we need to multiply the population of each county by yi's, whether or not county I is covered. We don't care if there is a PPB in a county. There can be counties where we don't have a PPB in there, but they're still covered because there is one PPB, at least one eligible PPB in one of its neighbors, right? So you count a population, you count a county in your population function as long as they're covered. And where do we get the population? We have it at row 94 here. So if you go down, these are my populations. So I just need maybe 2, 3 of them. I'm not gonna write down the whole function, but I'm just gonna keep these numbers just in case. So the population for the first county, 36, 369. This is the population for first county multiplied by Y1 plus population of the second county times Y2 plus 21, 302 times Y3, etc. And I'm gonna remove these numbers. So population reached, if Y1 is 0, meaning that county 1 is not covered, this will go away. This number multiplied by 0, it will be 0, so this will go away, meaning that this will not be counted as part of your population function. If Y1 is 1, meaning that county 1 is covered, this number, the population of county 1 times 1, this will be counted toward your population function. All right. So that's the objective function, and it will have 88 components, right? Because we have 88 counties. And then the constraints. So the constraints that we have one constraint here defined as the fixed number of PPBs. So we want number of PPBs established, which actually is x1 plus x2 plus all the way to x88. So this will capture the number of PPBs established. We want this to be fixed. Only a fixed number of PPBs can be established. You can put equal K, or you can put less than or equal to K. Either way, it's okay, right? Because our objective function is a maximization. Even if you put less than or equal to K, it'll make sure to make it binding, because you want to maximize the reach, population reached. So this will make sure to satisfy this at equality at K. But it's up to you. If you want to go with less than or equal to or equal, that's fine. So let me just call it fixed number of PPBs. So that is the first one. The second constraint, the second set of constraints would be to make sure actually connecting these two. We have a logical connection here. All right, we have a logical connection. That's all that we have to do for our formulation to be complete. We need to connect these xi's and yi's. So I would say xi's for county 1, so coverage constraints. But coverage constraints here are different from the problem 10. Here, coverage constraints, this is the logical constraints that we should have. Yi should be 1 only if xi's or sum of xi's for its neighbors plus its plus xi, sum of, let me just call it, yi should be 1 only if sum of xi's, and let me just call it xj, for when j is a neighbor of I plus xi greater than or equal to 1. So what I'm trying to say here is that as long as one of these values, either xi itself for the region I, for the county I, or one of its neighbors, I just called that j, and j can be any number as long as j it's in neighborhood of I, xj's plus xi, if the sum is 1, then you can have a you can count that county as being covered. So let me just make sure that I got it right. Yi should be 1 only if, so meaning that county I is covered if sum of xj's for when a j is a neighbor of I and xi greater than or equal to 1. meaning that there is at least one, only if there is at least one eligible PPB for county I. Which means that sum of xj's where j is a neighbor of I plus xi, when they're greater than or equal to 1, then you have at least one eligible PPB for county I, then you can have that. I hope it's not too complicated, but the meaning is very simple. You can count a county as covered only if one of its eligible neighbors or itself has a PPB, eligible PPB in it. All right, so that's the law of Ohio State. So for county 1, if we just do it for 1, we can just copy the logic. It will be exactly the same. For county 1, so what's the list of counties that can cover county 1? So let's go here, county 1 itself, county 2, 1, 2, 18, and 19. And I think that's it. 1, 2, 18, and 19. And anything else is not neighbor. Yeah, none of the other regions, none of the other counties are its neighbors. So for county 1, x1 plus x2 plus x18 plus x19. So this will give you the list of all PPBs, right? This will give you the number of PPBs that are eligible to cover county 1. As long as you have one of these, either in region 1, 2, 18, or 19. As long as you have at least one PPBs established in there, you can operate in county 1, meaning that county 1 is covered. You can have a branch there. So now you are able to count it. So once these are greater than or equal to 1, you can have y1. So now we need to connect these somehow to y1. And I'm going to do this. If x1 plus x2 plus x18 plus x19 greater than or equal to, as I said, if these are greater than or equal to 1, then y1 should be 1. Or I can write it this way. I'm not going to be able to write it in a conditional form. I have to come up with a linear form that captures that condition, captures what I have. Instead of I here, put 1 and just solve it for 1. Y1 should be 1 only if there's at least one eligible PPB for county 1, meaning that sum of x1 and all these xj's, where j is the neighbor of 1, so all these 3 plus x1, as long as these are greater than or equal to 1, then y1 can be 1. I'm just summarizing that into these form. All right. So now just take a look at this and see what happens. If xi's are, if these are 1, then if these are 1, 2, or 3, or 4, right? They can't be more than 4 because these are binary as well. Then y1 is allowed to take either 0 or 1. But since we're maximizing this objective function, it'll make sure to, if possible, for y1 to take 1, it'll make sure for y1 to take 1. But what happens if 4 of these are 0, meaning that we don't have any eligible county, any eligible PPB for county 1 to be covered? So if these are all zeros, so 0 less than or equal to y1. So y1 can be either 0 or 1. for these constraints to be satisfied, y1 has to be 0. All right. So if the left-hand side here is 0, y1 can only be either 0 or 1. It has to be 0 for these constraints to be satisfied, because 0 cannot be greater than or equal to 1. 0 can be greater than or equal to 0. So y1 will be forced to be 0 if these 4 are 0. So that's what this does. And let's just do it for county 2, and then let's go ahead and solve it. For county 2, list of counties that can cover county 2. 1, 2, 3, and 17, 18, and I think that's it. I think that's it, yes. Just to make sure, yeah. For county 2, x1 plus x2 plus x3 plus x17 plus x18, that should be greater than or equal to y2. And we can just keep going and do it for all these 88 counties. So you got the idea. The left-hand side is only sum of xi's that can cover county I greater than or equal to yi. So that's what we want to do. And that's actually wrap up. With that, we can wrap up the formulation for this problem. We have two sets of decision variables, xi's and yi's. Objective function is the maximum population reached. Constraints are, we have first the fixed number of PPBs, second coverage constraints, which in this case is actually connecting constraints. We are connecting xi's and yi's. And with that, we're done with the formulation. So let's go ahead, go to data sheet, and let's just go ahead and solve it. So I'm gonna define two variables. If xi, open PPB, and yi, is it covered? So these are basically the meaning of our decision variables, xi's and yi's. We want to know if we open a facility at counties one to 88. So I'm just going to highlight these two rows all the way to 88. So 88 times 2 variables. 88 xi's, 88 yi's. All right, so that's for decision variables. For objective function, we want to maximize the population reached, and maximize. Objective is the population to be reached, and we want to maximize it. So we want to find the sum product of the population of regions multiplied by whether or not they're covered. And that way we can find the objective function, which is the sum of population of counties that are covered. All right, B94 CK, B to CK. That's all good. Covered, yes. So the objective function here, and I think we're all we're done with the objective function. But for the constraints, we had two constraints. The first one was the fixed number of PPBs. The number of PPBs that are established is going to be sum of xi's and I'm just following my formulation. Even though I'm not looking at it, I'm actually this one, the one that I'm doing is this one. Sum of xi's equal k. Sum of xi's equals k. And k, it's for part B of this question, it asks for k of two PPBs, right? So k equal to 2. So that's the next one, the next constraint, fixed number of PPBs. And then for each county, we need to write down a connecting constraint. And I'm going to copy the list of counties, Control C, and I'm going to put it right here. And then for each one, we will do the number of counties, which is sum of xi's, counties to eligible to cover county I. Number of counties that are eligible to cover county I, and that would be some product of xi's, and for one, it's going to be xi's multiplied by multiplied by the first row. So some product of xi's and the coefficients in the neighborhood matrix, adjacency matrix. So if you just multiply those, it's just going to consider all those xi's for which you have 1 in this matrix, and it's going to drop all those xi's for which you have 0 in this matrix. So that is going to make sure that everything is correct. And I'm going to now we have all these left-hand sides for all these 88 counties. And then for the right-hand sides, they should all be greater than or equal to the yi's, right? Sum of xi's eligible to cover county I should be greater than or equal to yi. And then we're going to start with the first one. I just realized that my yi's, I want to copy again the formula y1, y2, y3, y4, and I have all my y's in one row rather than one column. So I'm going to transpose these row into one column, and I'm going to put it right here. Okay, so Control V and transpose. Is it covered yi? And then I also want to copy these, Control C, and transpose it here. Counties 1 all the way to 88. And by having those, I don't need this row anymore. So I'm just going to remove it. And And okay, so now we have one problem here for the population. We need to do, I'm just gonna do this, Control C, one last, and transpose it here, because the population function is gonna be some product of populations and decision variable yi, right? So I have to, that is necessary if you want to just make it a little faster. Otherwise you have to, I had to just do equal y1, then equal y2, equal y3, just to make it a little faster, yi. So let's just take a look at my objective function. That's perfect. My PPBs, xi's equals 2, and then number of counties eligible, or number of PPBs that are there to cover county I, would be some product of these and the row corresponding to each county. All right, so all is great. And now I can just go ahead and put equals y1. So county 1, the number of counties eligible to cover county 1 greater than or equal to y1 in this case, and then I just drag it down. And the last one, I could have used exactly the same thing. I could have even not write down the right hand side and just push these guys a little lower and then have them here. But what I've done now is also gonna work for sure. So these are yi's. So sum of xi's eligible greater than or equal to the yi's corresponding to each one, and then the formula. All right. So let's now go ahead and put it in the solver. So data tab. I don't have my solver, so I have to go back at it again. File, options. So now let's go ahead and put everything in the solver. So I want to maximize the population reached. So maximize the objective function by changing the xi's all the way to 88, x88, comma, and yi's. So yi's, and then selecting all the 88 of them, xi's and yi's, subject to we had two constraints. We wanted to keep the number of PPBs equal to 2. And also we had this connecting set of constraints, the left-hand sides greater than or equal to the right-hand sides. So 103 to 190, column H, column B. So this is great. And then, okay, I also need to make sure that I have my decision variables defined as binary variables. All of my xi's and yi's are binary. So I'm going to add, I just copied the changing variables here, the decision variables, add, call reference, binary. Okay, it's not gonna allow all of them to be defined at the same time. So now I have my xi's first, my xi's, B90, yes. So these are my xi's, and now I'm gonna add my yi's as well. So yi's, binary. Okay. So xi's, yi's, all of them should be binary. And then I have the minimum, I have the fixed number of PPBs, equal to 2 right here. And everything else is great. I have the connecting constraints, simplex LP for solving method. It's all good. Let's see if it gives us an optimal solution. Yes, so Excel found a feasible optimal solution. Let's take a look. So it found, the constraint is satisfied. It is going to find the number of counties that are covered, the number of counties that the number of PPBs equals to, but then how many counties are covered? Let's take a look. Sum of all these counties, sum of these guys is gonna give us the number of counties, total number of counties. We don't need this, but it's just for us to. This is a statistic for us. Number of counties that are covered is going to be sum of yi's. Sum of yi's, the total number of counties that are covered. This is the total population that is reached, 5,239,214. And then which counties are you building a PPB in? County number 11, and let's see, 11 and 77. So these are the locations that I'm building at, 11 and 77. Now, so this is the answer to part B of this question. For part C, what you're gonna do, you're gonna change this. So you would say K, 1, 2, all the way to 10. And then population reached. So for K equal to 2, this is the population reached, Control C, paste. So you're gonna now go back here. So this is the parameter that is going to change. So what you are doing in part C of this question, you're running a sensitivity analysis with respect to the number of PPBs. You want to see how your objective function is going to react to changes in the number of PPBs that you allow to be established. So you just change it to 1, 3, 4, 5, all the way to 10, and record the number of people, then the number of the actually population that can be reached using K number of PPBs. And then once you have all these numbers, draw a graph. And for graph, you can do a line chart, basically.